Hi everyone, this is Miss Ward. Tonight your notes are going to be over Concept 4 in our Motion in Two Dimensions unit, talking about projectile motion. So first thing is that in projectile motion, horizontal and vertical motion are independent of one another. We talked about this in class. This applies also to velocity and acceleration. X and Y in general are independent. We ignore air resistance in independent motion, or in projectile motion, because it's negligible and we want to assume an ideal situation. It's also important to note that acceleration due to gravity is going to be constant in that down direction of a 9.81 meters per second squared. So that ideal situation is when air resistance is being ignored. In cases where air resistance is important, projectiles deviate from that ideal behavior. So in situations where we have a strong wind, or you have a parachute type device, or any time in which air becomes important, they're not going to follow that ideal situation. Air resistance causes friction, and that's going to slow down something. So, for example, we can track a football throw because it creates that same projectile motion. So, the football is going to go up and then kind of come down. And if you wanted to figure out how long it take or how far you could throw a football, and if you have a strong wind going against the direction you're throwing it, you'd have to include wind, and that would definitely deviate how far you can throw it. And it's going to reduce the distance that a football could be thrown. So again, horizontal and vertical motion are independent of one another. It's important to know is that all of the variables are independent of x and y except for time. Time is dependent on vertical speed. So essentially how high something is from the ground. That's what time is going to depend on in essence. And that's what kind of goes to the example of the bullet leaving the gun and dropping a bullet at the same time. It doesn't matter that the one bullet is being shot at a vertical or at a horizontal velocity and the other one's just being dropped. They both reach the ground at the same time because that's the distance. But the amount of time that something has depends on how far something can go. So based off of when that bullet will hit the ground is how far that bullet can go in the x direction. So the x direction is very much dependent on that time, but that time is dependent on the y. So it transcends your x and y direction. So when we look at the motion equations for projectiles, it's important that you guys realize that these equations are the same as the ones we always look at. The only difference is instead of having it be x equals initial velocity times time plus 1/2 acceleration times squared, they're looking at, again, that delta x, where we have our final and we have the initial. So this is just taking into account that. Sometimes we'll use that equation, other times we'll use the more simplified equation. It just depends on the given information if they give you an initial x and a final x. And down here below, they show us these equations written in the x and y directions. We did this on the board in class this week, and you guys have seen this before. We talked in class how you can simplify these equations because there are certain constants that are always zero. Acceleration in the x direction, for example, is one thing that is always zero, and the acceleration in the y direction is always due to gravity. Alright, in most situations you're going to be looking at a negative gravity because most situations you would define I'll explain it in later when we do examples, but for the most part, generally you're going to have a negative direction or negative acceleration for y because it's be going against the motion or going against the distance, I guess you could say. So here are those equations simplified where they've eliminated the back half of the equation for the x direction. And really when looking at this, we should also eliminate this middle piece of the y because we know that initial velocity of y is always going to be 0. So it should really be final equals initial plus or minus, I guess, 1/2 of acceleration times time squared. Remember that g is another way of putting acceleration. Okay, here we have our quick example where a person skateboarding with a constant speed of 1.3 meters per second releases a ball from a height of 1.25 meters above the ground, given that the initial position of x is 0 and the initial position of y is 1.25 meters. Find x of f and y of f for the times of 0.250 seconds and 0.500 seconds. We're calling that g equals a 9.81 meters per second squared. Okay, here we have that given information gone ahead and I've wrote down for you. Okay, so I've got my chart on my left-hand side with all my given information. Initial velocity of x is 1.3, initial velocity of y is 0, acceleration of x is 0, acceleration of y is 9.81, initial position of x is 0, initial position of y is 1.25, final velocity of x is 1.3, final velocity of y we don't know, and then time for the first example is 0.25 for both. I wrote our equation out and then I simplified it to the x. I just eliminated this back half of the equation because for the x direction you don't need it. So they want us to solve for x of f. You simply plug in your pieces. In this case, the initial position of x is 0, so it's just that initial velocity of 1.3 times 0.25, which is x, final position of x equals 0.325. We should have 3 significant figures, which is what we have here. I did not write the numbers. They gave them to you in 3 significant figures. If you were to plug this in for the second one that they want you to solve for, where time equals 0.5 as well, then again, initial position is 0 plus 1.3 times 5, or 0.5 rather, then position of x would equal 0.650 meters. Okay, so then let's look at the y direction. Okay, in the y direction, final velocity or final position equals initial position plus 1/2 acceleration times squared. This piece cancels out in the middle because initial velocity is 0. Let's see, our initial position of y was 1.25 plus 1/2, and in this case again you're going to use that negative 9.81 because the position is the acceleration is going to be going against the position, so our final position is going to be lower than our initial position, times the time of 0.25 squared. So you take 0.25 squared times the negative 9.81 divide by 2. So y of f equals 1.25 minus 0.3. That's why it's important to use that negative, because obviously our final position would be lower than our initial position. So 1.25. So answer, you get y of f equals a 0.943 meters. If we do this with the other one, you're going to have, again, y of f equals, what was the number? Just 1.25. 1.25 plus 1/2 of 9.81 times 0.5 squared. 0.5 squared times 9.81 times 9.81 divided by 2. So, again, that's a negative. You get 1.25 minus 1.226. Make sure you guys don't round it to the very end so that way you don't lose any of your digits. You should get 0.0238, rounding off that last piece to 3 significant figures. And that's how you do it. So that's it for tonight. Make sure you go on and do all your WISC. When I check your notes tomorrow, I'll be checking concepts 1 through 4 to make sure they are done, as well as your WISCs. If you have any questions, please bring them to class tomorrow. Have a great night.